Hey everyone, so this is Miss Ward. This is your video to go over those forming compound notes. We've talked about this in class. This is just more information to help you make sure you understand. So again, we talked about this in class, that your ionic compounds are going to consist of two pieces, the metal and the non-metal. Because it's always going to be a cation and then an anion, your metals are going to be the ones losing electrons, so they become positively charged. And your nonmetals will gain the electrons, becoming negatively charged. So a metal with a positive and a nonmetal with a negative. They have to end up with a net overall charge of 0. So remember that when you form a compound, that means you have 2 or more different atoms bonded chemically, and the overall has to add up to 0. The chemical formula is what tells us the number of each type of atom in the compound. So, for example, if you had calcium and fluorine, okay, so that means calcium, and on your ion sheet, remember this is going to appear as fluoride. All right, so we have calcium, Ca2 positive, and F negative. If you add each of them up as they are with one of each, you get a 2 plus a negative 1, you get a positive 1 overall. It's not 0. So that means you have to take the superscripts and you have to switch them and make them subscripts. So the positive 2 becomes a 2 on the F, the negative 1 becomes a 1 on the calcium. All right, so you have, if you add those up, 2 plus 2 negative 1s, you get 0. So your overall is going to be CaF2. All you're doing is crisscrossing your charges. Here's an example with iron and oxygen, Fe3 positive and O2 negative. So they don't add up to 0, they add up to a positive 1. So you crisscross your charges. So if I took 2 times 3 positive, that's a positive 6. If I took 3 times a negative 2, it's a negative 6. Positive 6 minus 6 equals 0. So you know that it is done correctly. Fe2O3. Remember, if you see these 3 as a Roman numeral, that means that it is has multiple charges it could form. That is the charge, iron 3. If it already adds up to 0, then you don't have to add any subscripts. So Ca2 positive, S2 negative. Positive 2, negative 2 equals 0. Therefore, it's just CaS. All right, polyatomics. So which are groups of one or more elements with a charge. Okay, so you look at the bottom of the green sheet to see the number of negatively charged ions. So CO3, 2 negative. All right, remember there's only one positive polyatomic, NH4, ammonium. So the names of the polyatomics normally end in ate or ite. Some random examples are hydroxide, cyanide, peroxide, but generally they're going to end in ate or ite. Okay, remember those parentheses are going to keep the groups together. The charge is on the outside of the parentheses because the charge is with all of those elements added together. Same process is used, but the parentheses keep the polyatomics together. The only time you drop the parentheses is if the subscript for the group is 1. If you don't have to add anything, then that's the only time you can drop those parentheses. So strontium, PO4, 3 negative. Crisscross my charges. I get SR3, and then in parentheses, PO4, outside the parentheses is the 2. Rubidium and nitrite, so I have Rb positive, NO2 negative. When I crisscross them, a 1 is what would go on them, and actually they add up to 0, so you don't need to do any crisscrossing. You just smush them together. So you get RbNO2, which is perfectly acceptable. Or you can put parentheses around it if you really want to. But if you're not adding a subscript, you don't need to. Okay, this is all of the stuff you need for forming compounds. The rest of this is about some more notes about the history of the atom. This is the kind of stuff, the atomic theory things you need to make sure you know for your test. All right, there are 5 pieces of Dalton's atomic theory. There is a question on your test about which of the following is not part of Dalton's atomic theory, which means you need to know the 5 pieces of his atomic theory. So the 5 parts. Elements are made up of tiny particles called atoms. All atoms of an element are identical. The atoms of one element are different from any other element. Atoms of one element combine with atoms of other elements to form compounds. And finally, atoms cannot be created or destroyed. This is the law of conservation of matter. Chemical reactions are only changing the way the atoms are grouped together. They're not changing the amount or types of atoms. They're just altering how they're arranged. So elements are made of atoms. All the atoms in an element are identical. Every atom of an element is unique to itself. Atoms of one element can combine with other elements to make compounds. And then atoms cannot be created or destroyed. Whatever we have is whatever we've got. Those are the 5 steps of Dalton's atomic theory. You need to know them. The last thing is the law of constant composition. So that says that a given compound always has the same composition regardless of where it came from. I'm not going to go into a super deep example of all of these, just because we haven't looked at these sorts of models yet. But basically, all you guys need to know is that they're always going to be the same. So a sodium is always going to be a sodium, no matter where it comes from, how it comes from. It's always going to be that exact same thing. Electrons can move, okay, to make ionic compounds, but those electrons aren't going anywhere. The electron from sodium is just going over to the chlorine. It's not being lost. You're not losing it to, the world. It's just being moved from one spot to another. Nothing is ever leaving completely. Nothing's being destroyed. All right, that's it for these notes. Make sure you watch the other notes videos. Make sure you know what's going on, studying for your test. Your test is on Wednesday of next week. So if you have any questions, make sure you bring them to class on Monday. Have a great weekend.